Hello everyone, I, Arpita Tripathi, welcome you all to my channel and your learning platform, The World of Chemistry. Today, I'll continue my discussion from the last topic, atomic structure. So keep watching my videos and to know about my latest updates, do the needful. In this module, you'll get to know about valency, variable valency with few examples, Ionic bond, its definition and examples. So let's get into the discussion. Before knowing about valency, let's recall once what electronic configuration means. From the word electronic configuration, electronic means electrons and configuration means arrangement. So, electronic configuration is the arrangement of electrons in the various shells of an atom of the element. The maximum electrons which can be accommodated in K shell is 2, for L it is 8, for M it is 18 and for N it is 32. So, to obtain stability, the atoms need to have the octet configuration. It means the first shell should have maximum 2 electrons and second or third or fourth shell, whichever will be the outermost, will have maximum 8 electrons, that is the octet state. Now let's know about valency. It is the combining capacity of an atom of an element to form the chemical bond. Or it can also be defined as the number of valence electrons that can be lost or gained or shared to complete its octet. Now, we understood what valency is, but the important question arises is how to find it. Usually, metals have 1, 2 or 3 electrons in their valence shell. They lose these valence electrons during the chemical combination. So, the valency of a metal element is always equal to the number of valence electrons in its atom. For example, the valency of sodium, its electronic configuration is 2, 8, 1. So, it loses its 1 electron to obtain its octet configuration. Hence, the valency of sodium will be 1. Valency of magnesium. In magnesium, the outermost shell has 2 electrons. In order to become stable, it will lose 2 electrons and hence the valency will become 2. But in case of nonmetals, the valence shell contains 5, 6 or 7 electrons. Hence, they accept 3, 2 or 1 electron to complete the octet. So, the valency of a nonmetal element is usually equal to 8 minus the number of valence electrons in its atom. For example, valency of chlorine. In its outermost shell, the valence electrons present is 7. So, to become stable, it needs only 1 electron. Hence, the valency will be 8 minus 7, which is equal to 1. Now let's see the valency of oxygen. Its electronic configuration is 2, 6. So it needs 2 more electrons to become stable. Hence, the valency will become 8 minus 6, which is equal to 2. Exception is there. Hydrogen, being a non-metal, has the valency equal to its valence electrons, which is 1. The elements with valency 1 are the monovalent elements. For example, lithium, hydrogen, potassium, etc. The elements with valency 2 are divalent elements. Example, magnesium, calcium, sulfur, etc. The elements with valency 3 are trivalent elements. Example, aluminium, phosphorus, nitrogen, etc. The elements with valency 4 are tetravalent elements. Example, carbon, silicon, germanium, etc. Now let's know what is variable valency. Sometimes, because of different conditions under which a chemical reaction takes place, the valency of the same element changes. There are some elements which exhibits more than one valency. Such elements are known to have the variable valency. For example, copper, iron, lead, silver, mercury, they all have variable valencies. How the elements with variable valencies are named. Here is a list of elements showing variable valency. If an element exhibits two different positive valencies, then for the lower valency use the suffix OUS at the end of the name of the metal. For higher valency, use the suffix Ic at the end of the name of the metal. Here in the example you can see copper, its lower valency is 1, so accordingly it is named as cuprous. Its higher valency is 2, so it is named as cupric. And it goes on. Argentus, argentic. Mercury, it is mercurous, mercuric, and so on. The transfer or sharing of electrons between atoms leads to the formation of compounds, and the force with which these atoms are held together is called chemical bond. The bond in which one atom of an element transfers its valence electron with another atom of an element is called ionic or electrovalent bond. Some examples of compounds formed by ionic bond are sodium chloride, magnesium oxide, potassium oxide. So, I hope the content of this video will be helpful to you all. Thanks for watching and have a good day ahead.